Good morning, sir. We are from Group 5. We will explain about graphic media and audio with the topic electric and magnetic field. The members are Emeninta, Angelina, Natasya, Pelawi, Fitri Amalia, and Muthia Damayanti. Learning objectives. First, students can understand the meaning of graphic media. Second, students can create easy graphs using Microsoft Excel. Third, students can apply efficient and interesting graphics in learning. Definition of graphic media. Graphic media is a visual media that presents facts, ideas, or ideas through the presentation of words, sentences, numbers, symbols, or pictures. Graphics are usually used to attract attention, clarify the presentation of ideas, and illustrate facts so that they are interesting and memorable. The requirements of good graphic media. The first, efficiency. Graphics are made efficient in order to achieve learning with the efficient graphic media. It allows students to understand a lesson through the graph. Second, easy. Graphic media created using Microsoft Excel to make it easier. The third, interesting. The graphics made as interactive as possible so that the people can comfortably read it. Especially the those must match the lines so that the people don't misunderstand. Learning objective. Students can apply graphic media that is useful, effective, and supports learning in a learning material. Fourth, effective. By using graphic media, it can make learning more effective than not using a media as a tool. Students easily understand a data through the graph. Fifth, supports learning. In making graphs, we must provide clear explanations and points so that students are not wrong in making an explanation of the graph. Sixth, useful. With graphic media, it can be useful in a lesson. And with this media, students can understand data from the graph and can make their own conclusion on the graph.
The first phenomenon in the study of electricity is Coulomb's law. The learning objectives in this material are: first, students can understand the Coulomb's law formula. Second, students can apply the Coulomb's law formula. And third, students can analyze the constant related to the Coulomb's law formula. Coulomb's law, which states that the force on the charge will attract each other if the two charges are not like, and will repel each other if the two charges are the same. It formulated by the formula where force is equal to K times Q1 times Q2 divided by R squared. If we have the K is equal to 9 times 10 to the power of 9 and R squared is equal to 25 times 10 to the power of minus 5. If we put in the table where with the range where the Q1 times Q2 is 5, and we calculated the force by the formula, we have the force is equal to 80,000. And if we have the Q1 times Q2 is equal to 10, we have the force is equal to 36,000. And if we have the Q1 times Q2 is equal to 50, we have the force is equal to 54,000. If we have the Q1 times Q2 is equal to 20, we have the force is 72,000. And if we have the Q1 times Q2 is equal to 25, if we calculated the force, is this equal to the 90,000? And if we have the Q1 times Q2 is equal to 30, we have the force is equal to 108,000. And if we have the Q1 times Q2 is equal to 35, we have the force is equal to 126,000. And if we have the Q1 plus Q2 is equal to 40, we have the force it's equal to 144,000. If we have the Q1 times Q2 is equal to 45, we have the force it's equal to 162,000. If we have the Q1 times Q2 is equal to 50, if we calculated the force, it's equal to 180,000. Now, look closely to the graph. From the graphs of Phi and Q1 times Q2, we can see that the graph line is sloping linear line with increasing values. With the value increasing gradually as the range increases. The next phenomenon in electrical circuit is about electrical potential energy. Learning objective of this material is about first, student can understand the formula for electrical potential energy. Second, student can apply the formula for electrical potential energy. And third, student can analyze constant related to the formula for electrical potential energy. Electrical potential energy. If we make it into formula, we have the AP is equal to K times big Q times small q divided by R. If we have the K is equal to 9 times 10 to the power of 9 and AP is equal to 120,000, if we make it into table of the range where the big Q times small q, we have the 100. If we put it into formula and using mathematics, we have R is equal to 7,500,000. If we have the big Q times small q is equal to 90, we have the R is small to the 6,750,000. And if we have the big Q times small q is equal to 80, we have the R is equal to 6 million. If we have the big Q times small q is equal to 70, we have the R is equal to 5,150,000. And if we have the big Q times small q is equal to 60, we have the R is equal to 4,500,000. And if we have the big Q times small q is equal to 50, we have the R is equal to 3,750,000. And if we have the big Q times small q is equal to 40, we have the R is equal to 3 million. If we have the big Q times small q is equal to 30, we have the R is equal to 2,250,000. If we have the big Q times small q is equal to 20, we have the R is equal to 1,500,000. If we have the big Q times small q is equal to 10, we have the R is equal to 750,000. Look at the graph. From the graph of energy potential and big Q times small q, we can see that the graph line is sloping linear line, with the value increasing gradually as the range increases. Next is a phenomenon about electric potential. Learning objective of this material is about first, student can understand the formula for electrical potential. Second, student can apply the electric potential formula. And third, student can analyze the constant associated with the formula electric potential. Electric potential, we can make it into formula where the V is equal to K times Q divided by R. If we have the K is equal to 9 times 10 to the power of 9 and R is equal to 25 times 10 to the power of minus 5. If we make it into range of table and we have the Q is equal to 25. If we put it into mathematical formula, we can have the V or electric potential is equal to 90,000. And if we have the Q is equal to 30, we have the electric potential, it's 108,000. If we have the Q is equal to 35, we have the electric potential, it's equal to 126,000. If we have the Q is equal to 40, we have the electric potential is equal to 144,000. If we have the Q is equal to 45, we have the electric potential is equal to 162,000. If we have the Q is equal to 50, we have the electric potential is equal to 180,000. If we have the Q is equal to 55, we have the electric potential is equal to 198,000. If we have the Q is equal to 60, we have the electric potential is equal to 260,000. If we have the Q is equal to 65, we have the electric potential is equal to 234,000. If we have the Q, it's equal to 70. We have the electric potential with the equal of 252,000. Look closely at the electric potential graph. From the graphs of electric potential and Q and charge, we can see that the graph line is a sloping linear line with the value increasing gradually as the range increases. The next material is about Ohm's law. Learning objectives of this material are students can understand the formal Ohm's law. Second, students are able to apply Ohm's law formula. And third, students can analyze constants related to Ohm's law formula. Ohm's formula, we can make it into mathematically where the voltage equals to current times resistance. If we have the voltage is equal to 25 volt, if we make it into table of range and have the resistance is equal to 2 and E or current, we can have it what the mathematical is equal to 12.5. If we have the R is equal to T, we have the current it's equal to 8.33. And if we have the resistance is equal to 4, we have the current it's equal to 6.25. If we have the resistance is equal to 5, we have the current is equal to 5. If we have the resistance is equal to 6, we have the current is equal to 4.16. If we have the resistance is equal to 7, we have the current is equal to 3.571. If we have the resistance is equal to 8, we have the current is equal to 3.125. If we have the resistance is equal to 9, we have the current is equal to 2.77. If we have the resistance is equal to 10, we have the current is equal to 2.5. If we have the resistance it's equal to 11, we have the current is equal to 2.272. Look at the graph of Ohm's law. From the Ohm's law graph with a range of resistance and current, we have the hyperbolic line which will be formed in the graph.
And now we discuss about magnetic flux. The learning objectives are: the first, students are able to understand the formula of magnetic flux, and the second, students can analyze the relation between B and A. Magnetic flux is the number of lines of force that leave the north or N and enter the south pole or S. Flux is equals B times A, where flux is magnetic flux with the units of Weber, and A is area of the plane perpendicular to the magnetic field, or meter square. Because the formula of magnetic flux is B times A, we assume the value of B, or magnetic field, is 25 Tesla, and the value of A, or cross-sectional area, are 2, 4, 6, 8, and so on, 2 digits up to 20 meters square. Therefore, we can get the result of magnetic flux is 4 to meter square. The magnetic flux value is 50 Weber. For 4 meters square, the magnetic flux value is 100 Weber, and so on. And we can look on the graph. In horizontal line, or x-axis, showing the cross-sectional area, while in vertical line, or y-axis, showing the value of magnetic flux. So it can be concluded from the graph that this graph is linear with increasing constantly. And last one, also discussing about Lorentz force. The learning objectives, there are two learning objectives here. The first, students are able to understand the formula of Lorentz force in magnetic field charge moving. And the second, students can evaluate by the formula given. So Lorentz force on a charge moving in a magnetic field is F equals Q times V times B times sin theta, where Q is electric charge with the units of coulomb, and V is speed of charge with the units of meter per second. The formula of Lorentz force on a charge moving is F equals Q times V times B sin theta. We assume the value of V, or speed of charge, is 10 meter per second. The value of B, or magnetic induction, is 3 Tesla. And for the angle, the value of theta we assume is 90 degree, or equal to 1. Similar with previous, the value of Q, or electric charge, is starting from 1 until 10 coulomb. For the first electric charge, or Q, is 1 coulomb, we substitute the formula F equals Q times V times B sin theta. We get the F is 30 Newton. For the second electric charge is 2 coulomb, we substitute the formula, we get the F is 60 Newton, and so on, until we finish 2 electric charge in 10 coulomb. From the graph, we can see the horizontal line, or x-axis, is showing the value of Q, or electric charge, while in vertical line, or y-axis, is showing the value of F, or Lorentz force. So it can be concluded from the graph that this graph also linear and decreasing constantly. And next is about Lorentz force. The learning objectives, there are two learning objectives here. The first, students can calculate the Lorentz force and apply it. And students can understand the formula of Lorentz force and the use of it. The force that exists on a current carrying wire, or an electric charge that cuts across a magnetic field, or magnetic flux. In a current carrying wire, where F is Lorentz force with the units of Newton, L is length of wire with the units of meter, and theta is angle between I and B. The formula of Lorentz force on a current carrying wire, or an electric charge, is F equals B times I times L sin theta. We assume the value of B is 15 Tesla, and L is for the length of wire is 2.5 meter. For the angle, we assume the value of theta is 30 degree is equal to a half. And for the current, or I, is starting from 1 until 10 ampere. For the first current is 1 ampere, we substitute to formula F equals B times I times L sin theta. We get the F is 18.75 Newton. For the second current is 2 ampere, we substitute the formula, we get the F is 37.5 Newton, and so on, until we finish the current to 10 ampere. From the graph, we can see the horizontal line or x-axis is showing the value of I or current, and in vertical line or y-axis is showing the value of F or Lorentz force. So it can be concluded that the graph is linear and decreasing constantly. And then we discuss about magnetic induction. The learning objectives are students are able to explain the definition of magnetic induction, and students can evaluate the value of magnetic induction from the formula. Magnetic induction in various current carrying conductor around the long straight wire, where mu0 is permeability of vacuum. For P times 10 to the power minus 7 Tesla meter per ampere, and A is the distance from point to conductor. The formula of magnetic induction around a straight line is B equals mu0 times I over 2 times P times A, with the value of mu0 is 4P times 10 to the power minus 7, or 1.25 times 10 to the power minus 5 meter square per second. We assume the value of I or current is 5 ampere and the value of P is 3.14, and the value of A or distance to wire point are 1 to 10 meter. For the first distance, with A is 1 meter, and then substitute to B equals mu0 times I over 2 times P times A, we get B is 10 to the power minus 6 Tesla. For the second distance, with A is 2 meter, we get the value of B is 5 times 10 to the power minus 7 Tesla, and so on, until we get the last distance at A is 10 meter. From the graph, in horizontal line or x-axis showing the distance to the wire point or A, while in vertical line or y-axis showing the value of magnetic induction or B. So it can be concluded from the graph that this graph is decreasing and not constant.
That's all about our presentation. Thank you for your attention, sir.